Welcome to G Fun Facts Online. Today, we are traveling deep into the southern sky, specifically to the constellation Centaurus, roughly 135 million light-years from where you are sitting right now. We are going there to witness a monster wake-up. In the vast, silent vacuum of space, black holes are often thought of as sleeping giants, or perhaps more accurately, as static, unmoving drains that simply exist to swallow matter. But in late 2025, astronomers didn't just observe a supermassive black hole, they watched it breathe fire. For the first time in the history of astrophysics, humanity witnessed the direct cause-and-effect mechanics of a black hole launching a wind, and this wasn't just a breeze. It was a tsunami of ionized gas, blasted into the cosmos at nearly 20% the speed of light. That is roughly 60,000 kilometers per second. This event took place in the galaxy NGC 3783. To the casual observer looking through a backyard telescope, this galaxy looks like a picturesque pinwheel of starlight. But at its heart lies an active galactic nucleus, or AGN, powered by a supermassive black hole with a mass of 30 million suns. For decades, this object has been a laboratory for astronomers, a reliable beacon of X-rays and ultraviolet light. But the event captured in December 2025 was the smoking gun scientists had been waiting for. It bridges the gap between the microscopic world of quantum thermodynamics and the macroscopic grandeur of how galaxies evolve. To understand the gravity of this event, quite literally, we have to understand the environment. This black hole isn't sitting in isolation. It is surrounded by an accretion disk. Imagine a flat, swirling carousel of gas and dust, millions of kilometers wide, spinning at appreciable fractions of the speed of light. As matter falls toward the black hole, it creates a traffic jam of cosmic proportions. Friction between the layers of gas heats this disk to millions of degrees, causing it to glow brighter than a billion suns. Hovering above and below this disk is the corona. This is a chaotic cloud of superheated plasma, where electrons are stripped from atoms and whipped around by magnetic fields that are twisted and contorted by the spinning black hole. For years, astronomers knew that winds blew outward from these regions. These are streams of particles, protons, electrons, heavy ions of iron and oxygen, blasted into deep space. We call them ultra-fast outflows, or UFOs. But until the NGC 3783 event, we had a chicken and egg problem. We saw the winds, and we saw the X-ray flares that characterize black hole activity, but we had never seen the specific trigger. We had never watched a flare occur and immediately launch a wind. It was like finding bullet holes and hearing gunshots but never seeing the gun fire. On that fateful observation run in late 2025, the gun went off while we were looking right down the barrel. This discovery was a triumph of robotic collaboration, utilizing two of the most advanced X-ray observatories ever launched, the European Space Agency's XMM-Newton and JAXA's XRISM. XMM-Newton is the veteran. Launched back in 1999, its large mirrors are designed to scoop up as many X-ray photons as possible. It acts as the spotter. It monitored the overall brightness of the galaxy, waiting for a change. But the surgeon in this operation was XRISM. Launched in 2023, XRISM carries an instrument called Resolve. To call Resolve a camera is an insult to its engineering. It is a microcalorimeter. It is a device so sensitive, it does not just see light. It feels the heat of individual photons. When an X-ray photon from NGC 3783 hits Resolve's detector, it raises the temperature of the detector by a fraction of a thousandth of a degree. By measuring this tiny temperature spike, the instrument can determine the energy of that photon with unprecedented precision. And in astronomy, energy equals speed. By measuring the precise energy of X-ray photons emitted by iron atoms in the wind, astronomers can use the Doppler effect to calculate exactly how fast those atoms are moving. So, what exactly happened in the heart of NGC 3783? The data tells a story of magnetic violence. The accretion disk of a black hole is a plasma, a soup of charged particles. By the laws of electromagnetism, moving charges create magnetic fields. Because the disk is spinning, and spinning faster near the hole than at the edges, these magnetic field lines get dragged, twisted, and wound up like rubber bands on a toy airplane propeller. Eventually, the tension becomes too great. The magnetic field lines snap and realign in a lower energy configuration, a process called magnetic reconnection. This is the exact same mechanism that drives solar flares on our own sun. But on a black hole, the scale is billions of times more powerful. The sequence of events went like this. First, the magnetic fields in the corona became critically tangled. Second, the fields reconnected violently. This released a massive burst of energy, causing a sudden flash of soft X-rays which XMM-Newton saw as a sharp spike in brightness. Third, this energy acted like a piston. The sudden release of magnetic pressure blasted a blob of plasma out of the disk. Finally, the plasma was hurled outward, catching the light from the central black hole. XRISM watched as the spectral lines of iron suddenly shifted, indicating the gas was accelerating from 0 to 60,000 kilometers per second in a matter of hours. Let's pause to appreciate that number, 60,000 kilometers per second. The fastest man-made object, the Parker Solar Probe, travels at about 190 kilometers per second. The wind from this black hole travels 300 times faster. At this speed, you could travel from Earth to the Moon in 6 seconds. You could reach Mars in 10 minutes. This is a relativistic wind. At 20% the speed of light, the effects of Einstein's relativity become measurable. Time ticks slightly slower for the atoms in that wind than it does for us. The mass of the particles increases effectively. When XRISM analyzed the spectrum, it looked for the telltale absorption lines of highly ionized iron. These atoms have had almost all their 26 electrons stripped away by the intense heat. However, in the data from this event, these absorption lines were not where they were supposed to be on the spectrum. They were shifted massively to the blue part of the spectrum. This blue shift is the Doppler effect on steroids. Just as a siren sounds higher pitched as an ambulance races toward you, the X-ray pitch of the iron atoms was shifted higher because they were rushing toward Earth at 1/5 the speed of light. Now, why should we care about a wind blowing in a galaxy 135 million light-years away? Why does this matter to the grand scheme of the universe? It matters because these winds are the sculptors of galaxies. For decades, cosmologists faced a puzzle. Their computer simulations of the universe predicted that galaxies should be enormous, filled with massive, old stars. But in reality, galaxies are smaller and stopped growing earlier than predicted. Something was shutting them down. Something was preventing gas from cooling and condensing into new stars. That something is AGN feedback. The supermassive black hole at the center of a galaxy is tiny compared to the galaxy itself. It is like a grape in the middle of a football stadium. Yet, the energy released by that grape determines the fate of the entire stadium. The event in NGC 3783 provides the smoking gun for how this works. The winds launched by the black hole carry immense kinetic energy. As they smash into the surrounding gas of the galaxy, they create shockwaves. These shockwaves heat the gas, preventing it from cooling down to form stars. In extreme cases, the wind is powerful enough to blow the gas entirely out of the galaxy, starving it of the fuel needed for future star formation. By observing this event, astronomers calculated the energy budget of the wind. They found that a single event like this, if sustained or repeated, releases enough energy to unbind the gas of the entire stellar bulge of the galaxy. The black hole is not just a passive eater, it is a regulator. It decides when the galaxy stops growing. NGC 3783 has long been a pet galaxy for astronomers due to its orientation. We look almost face-on into the accretion disk. In the early 2000s, the Chandra Observatory revealed it was shrouded in clouds of warm gas, moving slowly at a few hundred kilometers per second. We call those warm absorbers. But the ultra-fast outflow observed by XRISM is different. The warm absorbers are likely the aftermath, the gas that is slowed down and piled up thousands of light-years away. The wind observed in 2025 is the fresh exhaust, the immediate output of the engine. One of the most beautiful aspects of this discovery is the unity of physics. The same equations that describe the behavior of the Sun describe the behavior of a supermassive black hole. On the Sun, magnetic field lines twist, snap, and release coronal mass ejections, blobs of plasma that can cause auroras on Earth. On NGC 3783, the black hole does the exact same thing. But because the gravity is millions of times stronger and the magnetic fields are millions of times more intense, the ejection is accelerated to relativistic speeds. It suggests that solar and high-energy physics work in surprisingly familiar ways throughout the universe. By studying our own Sun, we can learn about black holes, and by studying black holes, we can understand the extreme limits of plasma physics. This event is a teaser trailer for the future of astronomy. XRISM is a Pathfinder mission. In the 2030s, the European Space Agency plans to launch Athena, the advanced telescope for high-energy astrophysics. Athena will have a mirror vastly larger than XRISM and a calorimeter with even better resolution. Where XRISM saw this event as a point of light with a spectrum, Athena might be able to map the chemical composition of these winds in 3D, tracing the life cycle of matter from the edge of the event horizon to the intergalactic void. Combined with future gravitational wave detectors like LISA, we are entering the era of multi-messenger astronomy, where we watch the universe with eyes of light, ears of gravity, and sensors of particles. The NGC 3783 event of December 2025 will go down in textbooks as a turning point. It was the moment the feedback loop of the cosmos was closed. We moved from theoretical models of black hole winds to direct, real-time observation of their birth. We saw a monster in the dark. We saw it flash with the energy of a billion suns. And we saw it scream, launching a wind of iron and fire across the cosmos at the speed of light. It serves as a humbling reminder that the universe is not a static painting. It is a dynamic, violent, and interconnected machine, where the death of a magnetic field line on an event horizon can dictate the fate of a galaxy for billions of years. Thanks for listening to this deep dive on G Fun Facts Online.